Okay, let's get started. Well, first of all, this meeting is recorded. We're planning to post this on YouTube. So if, again, as usual, if anything occurs in the meeting that you want us to edit out, we'll do, but just let us know before the end. So our meeting agenda for today is a discussion on figures. The first one is a graphical abstract that we needed to put together for our submission. And so Christoph helped work on this with Benedict, and we iterated this figure. So we're in a stage where we are almost ready. So I want to make sure that everybody is on the same page on this figure. And then one of the figures of the paper triggered a longer discussion on the theoretical footings across different implementations of predictive coding. And so we actually ended up revising one of the figure of the paper to better align with the literature. And so I wanted to make sure we were on the same page with this change. So let's go with the first. Yeah, and so I want to acknowledge that Christoph couldn't make it today, but he agreed to, and Colleen as well, but they agreed to move forward with the discussion, and then we might have more online if need be. So let's discuss this graphical abstract. So this was an initial proposal by Christoph, and the idea is to highlight that our review summarize predictive processing mechanisms at different scale. And so what you see here on this figure is first on the top left, we start with the stimulus design, which is essentially the first part of the review. And then we move on to highlight the three major scales that were part of the paper: brain-wide computation, local computation in one area, and single cell or dendritic computation. And so we intentionally did not commit to a particular mechanism. So you see the errors are both ways, but the intent is to highlight that the review is touching all of those points. And the second point is we decided to focus on the mouse because this is where there's so much data on all of those levels. And so that's why we felt it was helpful to have a mouse picture on the top left just to highlight where this is coming from. Whereas, I mean, it's true that in our paper there are other species and humans, but that was the rationale for this choice. And so I think today we should just make sure that everybody's aligned, and then that you feel this figure is clear, because it's a very important figure. It will go on top of the publication. Other thoughts on this? Questions? Do you like it? Do you don't like it?
Jerome, as a newcomer to the group, I want to
Yes.
say that it's really beautiful. It represents most of the things which I think are in there, but I don't understand the arrows, because it almost seems that you're trying to put the global as more important, rather than necessarily zooming in or something like that, like a lens aspect. You create a hierarchy of importance for hierarchy of scales. Is that your intent?
I don't know if we initially intended to highlight one scale over the others. So is it your point about the blue arrows? These ones?
Yes, the big arrows between panels, between boxes.
It's just I think it was the natural ways to highlight those together, because you're zooming in, as you said. A challenge with this figure is that they have a really fixed X and Y ratio, so we have to go with a square like this. But how would you change it? What will be your suggestion?
Just have like a zoom in, almost like a lens going through. I can try to follow up to give you a sketch as to.
So no arrows, or?
No
The same.
arrows, just
Yeah.
very similar to that, but more like a box to try to represent what is the scale you're zooming in from one panel to the next.
Yeah.
But I mean, there are already boxes that are zoomed in, so maybe just the arrows are too much.
Yeah, that would suffice.
You see, like each box is zoomed on the previous stage.
Yeah, just physically linking one of the box to the other. That's all I think, which is needed. Emphasize that, or remove the arrows, and that would suffice for removing the hierarchy of importance.
I see. That's it, because this was not the intent. I think what we intended with the arrow is just to help people read the figure. But if you think that's making a statement, we could remove what other people think. Need his agreement with Stefan, or see if there's comments in the chat.
I don't think the errors necessarily have information, right? So I think Stefan is right that this sort of suggests a hierarchy that you can avoid.
Yeah.
So why not remove them? It also makes it cleaner, probably aesthetically.
That's right. It's fine with me. Okay. Doesn't seem like there are major concerns or comments. We could try without the arrows. It's fine with me.
Yeah, I have a question. Do you think the first arrow should be kept because it's not a zoom in for the first one between the visual stimuli and then the mouse?
Yeah, that one makes sense because that one is a
Okay.
true arrow
Okay.
for a relation.
Okay, thank you.
Is the box inside the stimulus clear to everyone? Because we had some internal discussion last week at the Allen, and some people were confused, so we made some edits. Is that figure with prediction stimulus error really clear? No concern, or? I don't hear any.
It seems clear to me. I mean.
Yeah. Okay. Well, I'll put the comments online, but it seems like we're well done. If we remove the arrows, mostly. Okay. Lucas, do you want to lead the next discussion? Oh, you're muted, or I can hear you. Oh, I can hear you now.
Oh, now it works?
Yes.
Okay, perfect. Yeah, so this was concerning figure 2, and exactly, yeah, thanks for pulling that up. Would you mind if I share my screen, because I have kind of an alternative version that we could discuss, but okay, do you see this Affinity Designer window now?
Yep.
Okay, perfect. All right, so we had a previous version where we had the hierarchical, like classical hierarchical predictive coding shown here in the panel A. Sorry, the A is cut out here. That's the top one. So this is just a classical hierarchical circuit. And then in panel B, we try to depict several proposals for how this could be implemented with positive and negative error neurons, because there's not really are a consensus, or there are different proposals at least. So and there, yeah, we had some discussions how to do this in a best way to fit with the context of the figure, but also including this influential proposal by Keller and Georg and Florian, and so this is a version now that Benedict put forward. So thanks a lot. Yeah, I can just say what the idea was. The left one is essentially just the version in A, but implemented with positive and yes.
I think some people can you make it slightly larger on your screen?
Oh yeah, for sure.
Just zoom in. That's it.
Yeah. It's, sorry, this is somehow. Oh no, it's working. Okay.
Thank you.
I just zoom into the ones that are interesting now. So the left-hand side, single area in line with panel A. So this is not the final title, but just for you to understand what it's doing. So it's essentially this, but implemented with positive and negative error neurons. Yeah, I hope this is everyone can kind of understand what's going on there. So splitting this error neuron in positive and negative. And the interesting thing is that the proposal by Keller and Georg and Florian is kind of doing the opposite thing, where essentially there's sensory input coming in, and thus the positive and negative error neurons integrate the signals with opposite sign. So that's a key difference in the way these circuits are arranged. And the thing is, they don't really propose how this could be embedded in a hierarchical circuit. So there's a new archive draft, actually very interesting paper from January, where they actually also put these two circuits, and they call this, and I move a bit here, hierarchical implementation and non-hierarchical implementation, which I guess makes sense in this, considering that this one has a clear integration into this hierarchical predictive coding context, and the other one, it's not really clear how this would be done. And I made some changes going from this initial proposal to a version that I would propose we include in the paper, where here we really see that, how it would be integrated in the hierarchy through these connections coming in and going out here. And for the non-hierarchical, I would propose we might omit those because it's not proposed in the original work. Yeah, this also makes it easier to understand these terms here. And then we can just say, well, these are two proposals that are out there. Let's say the classical one, which is the hierarchical implementation, and the non-hierarchical one that was proposed in this 2018 Neuron paper. There are a couple of other small details that I propose we would change. I would give the positive error the violet, because the positive error neuron is essentially doing the standard thing, let's say, in hierarchical predictive coding, whereas the negative one is essentially opposed polarity, or kind of sign inverted. So I would give this kind of a new color, like a new player coming in, essentially. So that's why going from here to here, I just changed the colors. I don't know what you think. And I just realized that this color code is also consistent with what we had with the dendrites previously. So the way it's depicted here, the violet dendrite is actually the positive error dendrite, I would say, because it's getting sensory input and subtracting the prediction. That's exactly the sign for the positive error dendrite, whereas the yellow one should be the negative. So that would then be consistent with if we just change here the legend, and in this plot change the colors. Yeah, and then one last thing that I added in this version is that that's something that they depict in their circuit, is that top-down predictions also essentially predict bottom-up input, which I guess is why they call this non-hierarchical, because it's kind of skipping a layer in that hierarchy. And if we want to stay as faithful or kind of a reproduction of what they show, I think we should also add them here. So that's essentially these lines here. Yeah, what do you think? Does that make sense? Is it confusing? What are your concerns?
You have two questions on the chat, Lucas.
Oh, could you read them out? That's easier for me.
So Sarah is asking, I'm a bit confused by the collaterals going nowhere. Do we really need these? I think she's referring to the axons that are going in and out of the box.
Yeah. Yeah, that's a good point. We could also omit them in this case here.
Which one?
So I guess she's referring to let's say this version, and then here it's this version. Like the outgoing.
This guy, but probably the collateral. Yeah, that goes.
Yeah, we could take them out. It's I had the feeling with the hierarchical implementation, at least this way, we kind of suggest that this is really implemented, and it's also clear how it would be implemented in a hierarchy. But I also see that it could be confusing. Yeah.
Karim disagree. Maybe can you raise your point, Karim? Or
yeah. Hi, Lucas. So in this panel B non-hierarchical implementation, I understand that the inputs are usually the bottom-up sensory input is coming through these blue axons.
Right.
So what is the output of that module?
Yeah,
the non-hierarchical module.
Yeah, that's a very good question, and we had a long discussion because it's never specified really in the original papers proposing this. They really just focus on how this error circuit is wired up, but it's exactly an open question, and that's what we try to put in here, kind of how this would then be embedded.
Yeah, I like that way, because it tells me, okay, it's easy to track. I can see, two, brown and purple coming in, and then, the module repeats. So they send something out, and then the blue from the pyramidal cell goes, communicates its output somewhere else. So I think these are informative, but I am puzzled with panel B, number sub figure 2.
Yeah. So you're referring to the right-hand one?
No, panel B, this non-hierarchical implementation.
Yeah.
Okay, there are two B's here. So
yeah,
the one on the right.
So this was the initial version. This kind of.
Okay. Now the new version, whatever on the right side. So this one doesn't have any output. So what does that mean?
Yeah. It's a question. If we want to stick as closely to the original proposal, where essentially they didn't propose anything, or we add what we think would be the consistent way with hierarchical predictive coding to embed this. But yeah, it's an open point. Sorry, just.
And I personally think we have to do the right thing in not leaving things ambiguous. I mean, no matter what they did, they maybe their figure wasn't very illustrative in terms of certain elements, but we we don't want to fall in the same, loophole here because it might raise some concerns, or reviewers might question that. So
I think that was our initial intent, Karim, is we were just filling in the parts that were not clear from the paper. That was focused on one area and just like, oh, how does it work if you have 2 or 3 areas? How do you wire it up? And we think if there were several ways to do it, essentially. And we chose one way initially, and then that triggered a long discussion between Lucas and John. So I want to bring in lots of people have thoughts here. Let's try to follow an order because I want to hear everyone. John, can you share your point of view?
Yeah. So I was still thinking the old version, last version is better. So I'm not saying it's a non-hierarchy implementation is like less supported. I'm just feeling for this review, we are starting from the different brain area, right? So we are talking about different hierarchy in the panel A already. And then suddenly we're talking about non-hierarchical thing. This feeling is like missing something there, right? And also, my criticism for the new word for color is that they're basically studying correlated discharge. So in their case, they don't require hierarchical organization to do the job. But what about other things like complicated outbound tasks? So it doesn't flow well with other part of the review paper. So that's why I'll say is the left side is better, and then just highlight that the interaction between the prediction units and units within a certain brain area can be excitatory or can be inhibitory. The sign can vary by different implementation, which the left version already serves the job, and we don't need to introduce more complication at this panel.
So you're referring to the left B with the 2 versions in panel B?
Yeah. I think the left panel B is better. So we just highlight the excitation synapses and inhibitory synapses are reversed. Then that's it.
Okay. Stefan?
Quite a lot of comments to begin on these. So first, there is a somewhat of a mixture between implementations done directly by neurons and what is going to be on a circuit. So having a constant representation as to what is there would be very important. Two, I would say that the input and output areas are kind of by definition the most important thing of the circuit, right? So having something which is like the panel on the right, which is non-hierarchical, which doesn't really have an output. The brain exists to have an output. I think if there is no prediction for that, it would be really weird to make that. So I would strongly vote for having a mechanism when one would try to fill in the gap as to how would this work, because it's the output of the circuit which actually matters for any type of computations. Other than that, I think that there are details. I think the figure in general is nice, but some of these things would have to be addressed to have a clear relation as to what is the input and output. If you start already with brain area 1, 2, and 3 in there, for that is typically hierarchical, potentially put an arrow, and typically have for hierarchical model on to lower areas to higher areas. And I don't fully understand, to be sincere, how the non-hierarchical model is supposed to work. But that is something which I think would be important to figure out, because from this representation it's very difficult to understand what's the difference.
I must say, it seems to me you're all calling to come back to the previous version of the figure. What do you think, Lucas?
Yeah, I'm totally in for both. To be honest, I just wanted to present these 2 possibilities, and I think it's good that everyone here essentially says proposing this without having an idea of how it's embedded in the circuit is tricky, and yeah, I think I second that. So I just wanted to put that option that we could also say, okay, let's just reproduce what others have done and then discuss it in the text. But I like the idea to fill it in. So then we would stick with the previous version. But what do you think of swapping the color code and with these consistence here with the error dendrites and so on?
Hold on. I think a lot of people are asking to see the previous version, so I'm gonna try to. And if you don't have it, Lucas, I need to pull it up.
Yeah, I'll stop and you can go ahead. That would be great.
Let me see if I can find it. That's right. Share my screen. Okay. Is that right, Lucas?
Yeah, I think this was the proposal that was out there before. Yeah.
So this wired up Georg and Keller with two areas, but the big debate we had is that what connects two areas was not specified in the paper. And so here we decided to have like errors goes down and prediction goes up, and so that's how we wired it up initially with positive and negative errors.
Right? It's errors going up and predictions going down, right?
Errors going
up and predictions going down in this version.
But why is the positive error not going from brain area 1 to 2? Or am I
so this
misreading
was Martin, we initially put it in the figure and it was very hard to read because you have now you have to there's so many wires.
Yeah, okay. One general comment, but I think one must somehow indicate that these are not cortical layers, right? Because that's very confusing if you compare this to the standard graphics or if that you find in all of the papers of Friston, that because here it suggests that the prediction units or the feedback comes from superficial layers and the feed forward comes from deeper ones, which is very confusing actually, right? Because in reality you assume that the prediction that there is a set of prediction neurons in deep layers that receive an input from superficial layers and then relay the feedback. So that, I mean, in the Rob Ballard paper, you have sort of representation units, prediction units, and error units, but they are subsets of projection cells that are in specific laminar compartments. So that this might be.
So
well, it has to be indicated, sort of, right? So
you're going to swap the figure up down. Is that what you said?
That could actually be an option, right? So that you see low and high.
That's right.
And that you're not getting confused by this being
on the top
layers. So if you would just rotate it counterclockwise.
Yep.
By 90 degrees, you would be there, I think, right?
We could also, because this is a specific proposal that might not be in agreement with Keller review perspective, but we could add another panel, David. Not David, Lucas. I mean, because we're essentially saying there are several ways to wire it up, and we don't know which one is true or they're true at all. And so the purpose of the review is to discuss those things so that we clarify what are the different threads. So if there is so much debate that we don't know, maybe it's worth highlighting the different options in another figure.
So you would suggest to have really the hierarchy shown in this one, so also to be in line with the other panels, and then we have a separate one where we discuss that, how you do that with positive and negative errors is really an open
That's right.
question. Yeah, I think that makes sense. It's a bit confusing in this version where we had like essentially we break and we say, okay, now this one area has different implementations and then all the others are hierarchies. Yeah, I agree with that. That could help. Yeah.
Stefan?
So as a quick proposal, a lot of the emphasis in here is done for the local circuit, and the connections between areas seem to be minimalized. And since there is confusion there, would it make more sense to try to separate and to have 3 boxes in every place, but one box to be an area, another box to be the connectors, how do they link together, and another box to be the upper area, and potentially have on the right panel multiple hypotheses about how you connect them? Would that make sense? Like a thin box in between the 1 and 2. And also just as a function of symmetry, it's easier to have the top one with just 2 areas as well, because it looks better as a figure, because you're just adding details to that. You're not adding areas in the prior one.
That's a separate statement. Yeah, here I think 3 areas on A is unnecessary. So you're proposing to add more elements here, is that right? That
No, not really to add more elements, but to create. So right now you've got brain area 1, brain area 2.
That's right.
Exactly as you have it, right? You've got a connection which is going to be from the negative neuron up, and from the prediction, whatever at the moment the color bars are weird there so from the purple neuron up and from the blue neuron down.
Yeah.
And if this is not the only option, if you've got the space in between, just define it as another box and have on the right alternative proposals for the linkage between the two.
I see.
Right. Very when you try to decompose functions, you'd think like a transfer function.
Yeah.
Which is going to be the module. You could even treat the area as a black box. Something is inside, and you've got different ways to connect the 2 black boxes. And the emphasis is one to look inside of the box, or the other is how do you connect the boxes. They think that at the moment, the tremendous emphasis in here, everything which is discussed is only what's inside the box. But the entire model and the theory would be complete only if you've got both descriptions. And to say, yeah, there are still unknowns. And for the connectors, which are going to exist, there are multiple hypotheses.
This is calling for more work, but I kind of like it. What other people think?
I have a hard time imagining it, how it works, to be honest, because it's somehow it's just that the number of neurons and connections are kind of the same order of magnitude here. So it seems that, it's hard to depict, one without the other, or I don't know. I've a hard time imagining it right now. How this would work.
I think the question, Stefan, is whether we need to describe all of those options in the figure or in the text, perhaps, right? Because I feel like there's so many different ways to wire this up. Just explode.
But I think it's totally fine if you put a box in the middle, right? Make it a little bit thicker, and you include and you say, I'm going to connect output 1 to input 1 and output 2 to input 2, or something like that. Describe it. And then to say, multiple alternatives exist, read the text. But at the moment, it's difficult to refer to that, what is going to be, right? There is no visual entity in the figure to try to describe and to try to logically separate the local structure versus the inter-region connection pattern. And I would say that both are important elements of the theory.
So you would just wire like a highway connection hub where there are different ways the car could go.
Yeah.
Sarah has some.
I'm happy to create a tiny sketch if you want to follow up.
Yeah. That would be helpful. This figures we pull our hairs on it already multiple times, so it's really helpful to have more input. Sarah said I read because I don't think she can speak. I think Stefan's idea is really good. Shifting the emphasis on clear from connection across modules versus within a simple way will help a lot. I think we need strong visuals, otherwise the text will be quite confusing. So she is on your page, Stefan. Martin, do you have more thoughts? I saw you made a comment.
Well, I think figure A is a bit confusing in relating it to figure panel B, right? Because A suggests the error neurons are negative there, but I think they're actually signed. So this would be sort of.
That's why we revised it, because it's but
okay.
The new one is consistent. But yeah, just coming back to that point, my problem is only that whatever is defined at the local circuit defines also how these are connected across the layers, right? To understand what type of error neuron it is and so on, that requires the local circuit, and then once that's defined, you also know how it should connect across areas. So that's why I have a bit problems figuring out like how one would do this with the boxes. But yeah, maybe if you Stefan, if you could make a sketch, then it might be easier for me to understand how this could work.
Right. So it sounds like we don't have consensus.
Well, what I heard through is that it's definitely confusing if we break this parallel structure in this figure and suddenly in B start depicting like individual local areas. So we need the connections between areas, and I think it's a perfect point. And then I would suggest for now we stick with the version, the updated version of B that's consistent with A, because it's just easier to embed that in the figure. And then what we can see, if either with Stefan's proposal, we manage to visually indicate that there are different options to why this, or we do it in the text, or we add another figure where we compare these local microcircuit like implementations with different wirings for the error neurons.
Yep. Does it make sense to try to have a discussion on this again next week? I feel like we're not finished.
Yeah. Let's add the updated version then for B. I will talk to Benedict to finalize that one. Then we can have this proposal and see if we want to add another figure or a different version.
That's right.
Yeah. But I want to say why we move to another the next version is because there are different way of implement like how the prediction and error units are connected. So if we're thinking about just like panel A is talking about the inter-area connection, then we don't need for the panel B, we still don't need to replicate for each area for the brain area 2 and brain area 1. Instead, we can propose what's the potentially connections such that in the new version, we can still say the excitatory synapse and inhibitory synapse are reverse for different implementation. And then we can also include the current panel C as a new subpanel of B, suggesting dendritic implementation is another way to implement that. But these
Yeah.
three are all like supposed to be local connection, so local implementation.
It does seem like we're trying to do two things. This is wired up areas and wired up local circuit, and so this may be two figures, or a bigger figure. But as Stefan suggested, sort of highlight the two aspects.
Yeah, it doesn't necessarily to be big, because currently panel B, bring area 1 and bring area 2 are just a replicate of each other, right?
That's right.
That's the same thing for C. So we don't need things to be replicated if we want to stress what's the inter-area connection and what's the within-area connection.
Sorry, Martin, you were going to say something?
No, I wanted to also comment, maybe it's also useful to indicate that figure A is just it lives strictly at the algorithmic level. These are not actually synapses, right? So you might actually, these are mathematical equations put into a circuit, and into boxes. So they are not really synapses, which is because if you strictly take this, it is wrong. So maybe one should replace it by arrows or by the classic circuit symbols, just indicated pluses and minuses, where then B becomes the actual implementational level, where it's clear that this is the actual implementational level that's then also unknown. And then Z zooms further into that, right? Because that prevents, I think, A being taken as an actual circuit model, which it is not.
That's right. Almost
So,
making the graphical abstract, but it seems like those two figures are somehow connected.
exactly, yeah, that could be indeed nice to maybe make it somehow similar to figure 1, right? Yeah, but B is just a possibility, right? Like
That's right.
Stefan, I mean, it could be anything. I mean, this is very likely to be wrong.
Oh yeah.
Yeah, so
That's the problem, is we want to respect the different proposals that are in the field and do not mischaracterize it, and at the same time highlight that there are many ways to slice this cake. All right. Stefan and Lucas, do you feel like you'll be willing to work together to make several proposals for next week? It feels like it would be nice if we could work together on that. And then Benedict is available probably to help you, but it's important.
Yeah.
It's important that you provide sketch, because otherwise it's difficult. Yeah. This is a complex diagram already. Okay. There is
Lucas, sorry.
Yeah, please,
Maybe
Martin.
it would be useful if Lucas, could you show your figure again? Because it has some elements maybe that might go in here, because you made some fixes, you said, right?
You muted, but
Did the share work?
Ah, yeah.
yes.
Okay. Yeah. So what I would suggest is to take the left-hand side of this B here, or actually, sorry, the hierarchical implementation, this one, and then we essentially repeat it. So we kick out this guy and just add this to show how these are interconnected, like it's shown in A.
So in B, it might be clearer if you replace those feed-forward connection and just merge them into sort of an abstract arrow, so that you make it sort of fake how that's actually connected then inter-areally, because that we don't know, right? Because now those lines are sort of coming out, but it's not actually clear they're inter-area connections. So if you go to panel B and you look at the yellow line going from area A to B, and the purple one, just to merge them into one feed-forward arrow, and just write FF on top of it or something, and then you have the feedback coming in also going into one area, so that part of the scheme is abstract and unknown, and then you have the local connections, right? That would make clear. Do you know what I mean? So in panel
think this
B,
is
the
what,
lines
yeah.
that emanate from the negative and the positive ones to just merge them into one big
I think this is,
arrow.
I think this is what Stefan was also alluding to, somehow. So you're sharing the same idea, which is great.
Like the entire area, we just do match check one, and yeah, you can.
That would probably help, yeah. And then maybe create a little bit of space between the two areas to actually make, well, if you would have two areas, but I think just showing one circuit and then having the input and the output, I think that would already be sort of clear. If you just label it with feedback, feed forward, then everything becomes more intuitive if you just have those labels there. And then, but I do think in figure A, you should not use the same color, the negative error color, because in that model it should be a positive, well, signed, right?
Yeah,
So maybe
that's why this one is the correct color.
I see.
yeah.
That's right. That's right.
So maybe make it a merge of yellow and purple, or a
Red.
yellow purple, both. Yeah, I don't know, or maybe half purple, half yellow, or something like this, to emphasize that it is signed. But in any case, panel A should be abstract, I think. I wouldn't show synapses there, right? This is just pure algorithmic level.
Yeah. Just one question. So in this hierarchical implementation one, so which would be the, let's say, the version we propose because it's in line with A. It's just that, whatever comes in, the nature of that determines where it's going, like whether it's going to the interneuron or whether it's going to the prediction neuron directly. So you would solve that by just saying it's like an arrow coming in like to this level here, or
Exactly.
okay.
Just feed forward, right? Yeah. And then you leave it sort of open because you don't know. If that is the unknown, then it's actually clearer to just make that an arrow that sort of merges. So yeah, then it's clear you don't know how that actually connects. Perhaps, but there are many mathematically equivalent ways to wire this up, as you know, right? So it's infinite many. So
yeah,
thank you, Stefan.
Just as a quick schematic as to what I'll show about trying things like this, but of course a little bit better drawn to try to, this would be the equivalent of panel A, to try to emphasize the differences between within area and between area, and to be able to describe them. I'll follow up next week just to have an idea as to what I had in mind. Sorry, because I don't think that I could verbally explain it very well.
I don't think anybody can, Stefan.
Okay.
Not to discard anybody in the room, but I feel like it's a complex one. All right. So we'll meet again next week to discuss boosts. It sounds like it might take the whole session. Is that right? It's the core of the piece. I think it makes sense that we spend time on the figure, to me. Okay. Any other questions?
well, you might also, well, I did this bit, but there are, of course, there are also models with stewardship, for example, right, where there are very specific proposals about where precision is encoded and that certain layers are encoding precision. I don't think you want to go there, but it should be somehow maybe at least referenced or mentioned, right? Because this is not yet figuring in the circuit, but Chip and stewardship and Kristen have quite specific proposals where that would actually be encoded in the circuit.
Yeah.
Since we have a section on precision somewhere.
That's right. It's in the text, but
yeah, exactly.
I think like the text of this figure will need to be edited for sure.
Yeah.
And so your input there will be valuable as well. but I think we need to finish the figure. Okay, any other comments?
Maybe one last, could you call the interneuron the inhibitory interneuron at least? Because it's technically could be excitatory. Yeah, okay, thanks.
That makes sense.
Just a quick question, Jerome. This is for the physiological review thing, right?
Yeah.
Yeah, and then was this specifically asked by the reviewer?
No. This is
Okay.
what happened is we with Colleen we decided to redo the figures to improve their harmonization style across the whole thing, and so that's what we ended up doing. And then as we did this, stumbled upon this problem, but it wasn't clear to many of us, and so that discussion was triggered.
Cool, thanks.
Any other comment? Appreciate everyone's patience. I'm sorry. I'm sure you want to get this done, but it's a big review. Thank you, everyone.
Bye-bye.
Bye.
Ciao, ciao.